Why optimize dowel designs? The common guidance for dowel bars, 1/8 of the slab thickness, spaced at 12 inches on centre and made from round, smooth steel. This originates from a subcommittee report to ACI Committee 325, which focuses on concrete roadway pavements. This report, titled Structural Design Consideration for Pavement Joints, was written over 70 years ago. It summarized the best available understanding of dowel bar design, testing and performance at that time. In that report, the committee recommended using the common round steel dowel for load transfer and noted that, in current practice, the spacing ranges from 12 to 15 inches. But let's remember that context. This was 1950s America, prosperous with steel readily available and inexpensive. Today, sustainability and value engineering play a far greater role in design decisions, and manufacturing advancements now allow for non-round dowels like elliptical or plate dowels with a range of different geometries to be produced competitively. Even the original report acknowledged that if proprietary load transfer devices are used, then their performance must be equal to or better than the round steel dowels. And they clearly stated the required spacing of dowels is dependent on design requirements. That report wasn't a final answer. It was a summary of considerations, not a universal solution that could always be applied at reasonable cost or environmental footprint. Since then, load magnitudes and contact areas have changed dramatically. On roadways, hard rubber tyres gave way to pneumatic ones, which have lower contact pressure. In industrial settings, market demand for faster and more efficient material handling has led to smaller, harder wheels, resulting in inline loads that directly impact joints. At the heavy end of the spectrum, equipment like straddle carriers used for moving shipping containers continue to grow in scale with time. One real-world example where the Dowel Optimizer was applied involved a 50,000-pound single tyre load, with a footprint of 15 by 15 inches on an 8-inch slab. Because that loading exceeded the range on the online tool, a spreadsheet version was used instead. Ultimately, American highway engineers recommended 1-inch round dowels at 8 inches on centre or 1/4-inch diamond-shaped plate dowels at 12 inches on centre. Following ACI guidance, though, would have likely specified 1-inch round dowels at 12 inches or diamond-shaped plate dowels at 18 inches. In this case, the Dowel Optimizer showed that for round dowels, the controlling failure mode was concrete bearing, and for diamond-shaped plate dowels, it was concrete shear cone. This illustrates the risk of blindly applying outdated guidance. Standardized tables from the 1950s weren't made to accommodate today's heavier, more complex loads. Let's consider another example. Still an 8-inch slab, but this time the load comes from a pallet lift truck with an 8,000-pound capacity. Its wheel loads are around 3,500 pounds, but the wheels are only 18 inches apart, which is close enough to interact. More importantly, while the 50,000-pound pneumatic tyre case allowed for 0.035 inches of joint deflection under load, here, per ACI 360, deflection is limited to just 0.01 inches. That's about 10 human hairs, a tiny movement tolerance. With such strict deflection limits, that deflection, not concrete shear or bearing, controls the design. Even so, the optimized solution came out 3/4-inch round dowels at 21 inches on centre. Compare that to the standard ACI recommendation, 1-inch round dowels at 12 inches. More than twice as much steel. The Dowel Optimizer also revealed other viable options. Single or double tapered plates at 24 inches on centre, or 1/4 inch diamond shaped plate dowels at 30 inches for construction joints only. In all cases, less steel and wider spacing than ACI guidance. Only through optimization can we develop site-specific designs that minimize steel use, control costs, and reduce the carbon footprint of the pavement or slab. That's why we optimize, to make sure the right dowel design is used for your specific project, balancing performance, cost, and sustainability. Use the Dowel Optimizer to do just that.